Good morning, Mrs. Berg's math students. Today is Thursday, April the 9th, and welcome to math class. Today we're going to be working on lesson 12, constructing the coordinate plane. So for today's lessons, you are going to need your math notes for lesson 12. Let me get a little closer for you there. You're going to need at least 2 highlighters or 2 colored pencils, just 2 somethings, and something to write with. All right, now we're still going to be doing a couple more lessons on the coordinate plane. Hopefully by now you're super familiar with how the coordinate plane looks, how we plot points on the coordinate plane, but today will just be a little extension from yesterday's lesson. But today, just like the lesson says, you're going to be constructing, so we're going to be making coordinate planes. We're going to have to decide how to number our y in our x and our y axes and where to put the points. So let's start with a little warm-up today. English winter. So you can see that the following data was collected over one December afternoon in England. It's going to start at noon, so let's actually, I don't like that it's a 0, so I'm going to make this noon, so 12 o'clock, and then 1 o'clock, 2 o'clock, all the way down to 8 p.m. These are the temperatures. You can see that it starts at 5. The temperature is 5 degrees Celsius at noon, but as the day goes on, at about 8 p.m., the temperature is now dropped all the way to -4. So hopefully you've noticed there's been a decrease. Turn my paper here. In the temperatures by hour. So on the side here, they have shown us grid A, coordinate plane A, coordinate plane B, and coordinate plane C. One of these is the one we want to use if we're going to take all this information and plot it on one of these coordinate planes. So question 1 says, which set of axes would you choose to represent these data? All right, so we have A, B, and C. So let's just write A and B and C. So we're going to pick one of these. So let's look a little closer at these. Now, if you noticed, if we look a little closer, okay, we can see that we have our x coordinates would be the time, and our y coordinate, all right, would be the temperature, and we would be plotting the points as such. So each of these would be an ordered pair. Like an example, this would be 12 and 5. The next one ordered pair would be 1 and 3. The next ordered pair would be 2 and 4. The next ordered pair would be 3 and 2. So on and so forth all the way down. All right. So if we look at this first A here, I noticed that it is only one part of the coordinate plane. We've got an X and a Y, all positive numbers. So this would really be just quadrant 1. And that's not going to work for us because we have some negative y's down here when the temperature drops below 0. But this coordinate plane there's no negative numbers anywhere because it's just only quadrant 1. So there's no way that A is going to work. We couldn't plot our ordered pairs on A. If we look at B, okay, I do see now that I see all 4 quadrants, 1, 2, 3, and 4. I see negative integers, which would work for our negative y coordinates. I notice that the x goes from 2 to 10, and I notice that my y's go from 8 all the way down to -6. So I could easily plot all of these numbers on this coordinate plane. All of my ordered pairs would fit. So B's looking really good right about now, but let's just make sure C isn't even going to be better. So if I look at C, I see again quadrant 1, 2, 3, and 4, all 4 quadrants. I see positive x's and negative y's, which I need. But when you look a little closer, I noticed that these lines skip count by 10s. It goes 0, 10, 20, 30, 40. Same thing with the y-axis, 0, 10, 20, 30, and then 0, -10, -20. But when I look at my numbers up here, there are not a lot of big numbers. 1 and 3, 2 and 4, 3 and 2. I don't hardly see any numbers that are in the 10s and the 20s and the 30s. So if I were to use this one, literally all of my points would probably be right in here, this little section. And the rest of it, I'm not even going to be using. I wouldn't use any rest. So I would have to squeeze a big table right here. So this is probably not the best one. So I think with everything that we just discussed, your best choice is going to be grid B. So I'm going to circle B. Number 2 is explain why the 2 sets did not seem to be appropriate. Well, we kind of just talked about that, but let's just write it in our math notes. We didn't pick grid A because it had no negative numbers. That's why I didn't choose A, because we have negative numbers right here, but there weren't any negatives on coordinate plane A. We didn't pick C because all the data would be crammed into a very small space on the plane. So this first warm-up, guys, was just to, again, kind of get you in practice on what makes a good plane for plotting ordered pairs and what does not. So let's go ahead and turn your page and get into the meat of today's lesson. We're going to be doing some drawing, okay? We're going to be, if you notice, this is a totally blank grid. All right, we have to draw our own coordinate plane on this blank grid. We've got to plot our points, okay, on this blank grid. So there's A, B, and I think there's one on the flip side. So let's just go ahead and start with A. Let me just zoom in just a little bit closer for us. So before we can even start to draw our y-axis and our, I'm sorry, I said that backwards, our x-axis and our y-axis, we've got to figure out how we're going to number, okay, each of these lines. Are we going to do it by 1s? Are we going to skip count by 2s or 5s or 10s? Or what are we going to do? So we really have to take a close look at our ordered pair. So this is how you have to start. Your first step when you're building your own coordinate plane is to look at your ordered pairs. Now remember, the first number is your x, the second number is your y. So I'm just going to go through here and I'm going to put x's above the x coordinates and a y above the y coordinates. All right. Now the next thing I'm going to do is I'm going to come over here to my side and I'm going to take a closer look at my x values only. So I'm going to say x values. Now this is important. You kind of have to take these steps before we just start drawing anything. So I'm just going to simply list all my x coordinates. So I have a 1, a 3, a -5, and a 0. These were my x coordinates to my ordered pairs. My range, okay, is my lowest, which is -5, all the way to my highest, which is number 3. So I need to make sure that I've got -5 all the way up to +3 when I start drawing my grid. Now we have to do exactly the same thing for the y. So my y values, I'm just going to list my y coordinates, 2, -4, -2, and 2.5. I'm going to now do my range for my y coordinates. And my range would be my lowest, so that's my -4, all the way through my highest, which is 2.5. So this range for my x's and my y's, that's going to kind of tell me how I want to set up and label my grid. So I can see that they're smaller numbers. None of these numbers are greater than 10 or less than -10. So I can easily just have each of these lines in my grid be equal to a value of 1. So I'm going to start with my orange. I'm just picking orange. And I'm just going to kind of draw straight, kind of cut my grid in half, and then kind of cut it in half again. Now, I'm going to label. So, I'm just simply going to go through and go 1, 2, 3, 4, 5, 6. These are positives. Going up the y-axis, 1, 2, 3, 4, 5. Those are also positive numbers. Now moving over here, these are going to be negative numbers. So -1, -2, -3, -4, -5, -6. And coming down, these are also going to be my negative y's. -1, -2, -3, -4, -5. Now I'll come back up here and I'll plot my ordered pairs. So the first one is +1, +2, so it's going to go right here. My next ordered pair is +3, 1, 2, 3, and -4, 1, 2, 3, -4. So that's down here in quadrant 4. Then I have a -5, -2. So I'm going to go over -5, 1, 2, 3, 4, 5, and I'm going to go down -2, 1, 2. This lands in our quadrant 3. In my last one, it's 0, so I'm not moving, and I'm going up 2.5, so 1, 2, and then up a half. That point is right on the y-axis. And that's all you have to do. But there are some steps you have to take, and you have to do them in the right order so that your coordinate plane looks good when you're all finished. That was just using onesies. Now let's look at B. If you noticed, we've got some bigger points that we're going to be dealing with. So just like we did up at example A, first thing we're going to do is we're going to make a list of our x values. So I've got 50, 0, -10, -35. So my range for my x values, my lowest number is -35, and my highest number was 50. Do the same thing for your y values. I have a 50, a 0, a -30, and a 40. So my range for my y coordinates, my lowest was -30, and my highest was 50. So this is what I'm focusing on here, my ranges of x's and my range for the y's. This is what's going to help me determine how I'm going to label my coordinate plane. So I can see these are bigger numbers, so I'm not going to use 1s. I would not have enough lines. I'm not going to use 2s. I'm thinking maybe 5s or 10s. But I'm looking at majority of these are just whole numbers except for 35. So I'm going to go with skip counting by 10. So once again, I'm just going to divide my coordinate plane kind of in half with my x and my y. I have my x-axis and I have my y-axis. And I'm going to label these skip counting by 10. So of course the intersection is always 0, 10, 20, 30, 40, 50, 60. I can stop at 60. My numbers don't go greater than 50, so I don't have to go any farther. Going up on my y, these are also positive numbers, so 10, 20, 30, 40, 50. Now going to the left of 0 on the x-axis, these are negative numbers, so I'm going to have -10, -20, -30, -40, -50, and one more, -60. And then coming down from my y-axis, these will also be negative numbers. I'm going to squeeze a -10 in there, -20, -30, -40, -50. Hey, yeah, it takes a little time, but that's just how you have to do it. Now let's plot our ordered pairs. The first pair is 50, 50. Over 50, up to 50, plot your point. Next ordered pair, well, that's 0, 0, so it's right there, right in the middle of our plane. Third ordered pair, -10, -30. Go over -10, come down, -30, plot your point. And the last ordered pair, again, over -30 and then 35, and then up 40. So we're right up here. And we have 1, 2, 3, and those are our 4 points. Okay. Now let's do one more. Oops. Okay, this one, if you noticed, we've got fractions, we've got a mixed number, we've got some positive numbers and negative numbers. So this is the ordered pairs we're working with, and we have to plot them on this grid. Now the first thing I noticed, and hopefully you might have noticed this too when you're working with fractions, is most of these have the same denominator. There are a couple, such as 1/2, -1/2, that have different denominators. I also noticed a mixed number. So the first thing you want to do is get all of your fractions to have the same denominator and have them all be in fractions. It'll make your life a lot easier when we start plotting points. So obviously, since the majority of the denominators are 4, I'm going to quickly change my 1/2 and -1/2 to have a denominator of 4. So 1/2 is now going to become 2 over 4, and -1/2 is going to become -2 over 4. Because obviously 2 over 4 reduces down to 1/2. My mixed number, I'm going to change it to an improper fraction. 4 times 1 is 4, plus 1 is 5, so this becomes -5 over 4. It'll just make things a lot easier when all of your fractions are the same denominators. Now let's go ahead and determine our x values, just like we did before. I've got a 1/4. I've got a -5 over 4, another -5 over 4, and another 1/4. Some repeating numbers. My range for my x's, my lowest fraction is -5 over 4, and my highest fraction is 1/4. Do the same thing for your y values. My y coordinates are 3 over 4, 2 over 4, -3 over 4, and -2 over 4, which makes my range for my y values, my lowest fraction is -3 over 4, but my highest fraction is +3 over 4. So now, just like the 2 times before, I'm going to take special attention to my 2 ranges to figure out how I want to label my lines to make a coordinate plane. All right, I've got fractions, they end in fourths, so the most logical thing to do is make each one of these lines be equal to a fourth. So let's go ahead and split again, right down the middle. We've got x-axis, the y-axis. Zoom out a little bit here. There you go. Let's start labeling. Of course, the intersection is 0. Then we have 1/4, 2/4, 3/4, 4/4, and 5/4. And you can stop at 5/4 because we don't have anything greater than 5/4, so we don't have to go any farther than that. Going up, these are all positive, so once again we have 1/4, 2/4, 3/4, 4/4, and 5/4. Over here, this part of our x-axis are negative numbers, so -1/4, -2/4, -3/4, -4/4, and -5/4. And the last one, again, going down, these are negative y coordinates. So we have -1/4, -2/4, -3/4, -4/4, and -5/4. That's the longest part of the whole problem. Easy part, plotting your ordered pair. So let's start with the first one. 1/4, go over 1, go up to 3/4. You're right here. Next ordered pair, -5/4, then up to 2/4, right here. Third ordered pair, again, that's why I wanted you to change it, -5/4. So again, going over to -5/4, but now we're going to go down to 3/4. So you're over here in quadrant 3. And the last one, +1/4 and down -2/4. You're right here. 1, 2, 3, 4. Those are our 4 points. Okay. We're not doing number 2 because it talks about discussing with the partner, and you guys are working solo today. All right, the last part of today's lesson. I don't know how many of you guys ever did mazes when you were young, or maybe some of you do them now, but you should be kind of familiar with a maze. You have an entrance point, and you got to figure out how you're going to get through the maze to come all the way down to the exit point. Okay, and this is why this activity is called Positively Amazing. This is a maze, and they put it on top of a coordinate plane. The black point in the center, right here, is your 0, 0. I don't know if you guys can see the yellow very well. Maybe I'll do orange. Is where you'd find 0, 0. Okay, so this is where we would have our y-axis intersect with our x-axis. So let's just go ahead with your highlighter or colored pencil and draw that in so it looks more like a coordinate plane. All right, each of these squares, this is important, is 2 units. Okay, so they have skip counted by 2. So we'll just label one of them. So this would be like 2, 4, 6, 8, 10, 12. Okay, and obviously we could do that all the way around. I just don't want to I don't want to write too much on here because it could get kind of messy. So I want to keep it pretty clean. It says for problem 1, you're going to enter the above maze in the location marked with a green segment. Well, we don't have color right now, so I will color this in, but here is your entrance point way up there. Your exit point, guys, is down here. This is where we have to get to. So we have to enter the maze here, go all the way around, exit the maze down here. All right, so this is going to be point A, our starting point. Draw line segments to show your way through and out of the maze. Label each turning point with a letter. Then list all the letters and write their coordinates. So I'm going to kind of do this as we go along, so it makes it easy for us. So A, let's figure out where we are with A. All right, so again, if we're skip counting by 2, 2, 4, 6, 8, 10, -10 is right here, and it's one more, so it's -11 is your x. Then we're going up 2, 4, 6, 8, plus one more is 9. So A is sitting at the -11, +9 ordered pair. All right, so you write that down. Then we're going to move and stop because we're going to be making a turn. So this is going to be labeled point B. And I'm going to put a B down here. So let's see where we are with B. 2, 4, 6, plus one more is -7, and then 2, 4, 6, 8, plus one more is 9. So now B is at -7, +9. Now we're going to come down. It kind of got the first 3 started for us. And this is point C. C is at 2, 4, 6, -7, 2, 4, plus one more 5. So C is sitting at -7, +5. Now we're on our own. So let's see where we're going to go next. So we want to just keep going. So I'm going to turn and go all the way over and stop right here because I see an opening. So I'm going to label this point D. And then let's write the ordered pair. So D is sitting at +1, 2, 4, and +5. So 1 and 5. Our next point is going to be E. Now E is going to be real short. Boom. I can only go down 1 square because here's a dark line here, so I can't go through it. So this is E. E is sitting at, again, positive 1, and then another 1, 2. So 1 and 3. Over 1, up 2, plus 1 more is 3. Now I can come all the way across and stop right here. Again, I see another place where I can turn. I'm going to label that F. F is at positive 7, positive 3, so 7 and 3. Now, this is a good one. I can actually come all the way down to right here. And this is going to be G. So G is going to be at positive 7, and then 2, 4, 6, 8, plus 1 more, negative 9. So 7, negative 9 is the ordered pair for G. I'm going to come down. Now I'm going to go all the way across and stop right here. This is H. And H is at negative 1, and then 2, 4, 6, 8, negative 9. Negative 1, negative 9. Now I'm going to come up to I. I is going to be at negative 1, 2, 4, and negative 5. Negative 1, negative 5. Now I can go, I'm so close, go right here. I can see the home stretch. Forgot to highlight as we go across. This is H-I-J. J is at 2, 4, negative 5, and negative 5, negative 5, negative 5. And then I come all the way, boom, I'm out. This is my last one, K. K. K is at negative 5. And where are we here? Let's see here. 2, 4, 6, 8, 10, 12, 14, 15. Negative 15. Okay. And we're not going to do number 2, so you can cross out number 2. That was just kind of a fun way to end today's lesson. So, with that being said, that is today's math lesson. So it is time for your homework, right? You're going to pause the video so you can do your practice problems. Make sure on your line paper, again, you are labeling with your name and number. Today's, we're in Unit 7. This is Lesson 12. You have One Khan Academy as well. So go ahead and pause the video and then come on back for your practice problem review. Welcome back to practice problems. Okay, this is, again, Lesson 12, Unit 7, Constructing the Coordinate Plane. So let me get a little closer here now. So let's look at the first one and see how well you guys did on your homework. It says, draw and label an appropriate pair of axes and plot the points. So here's just the X and the Y, and that's all you've got. You've got A, B, C, and D. So again, just like we were doing on the notes, first thing we have to do is plug in the X values. So it's 1 and negative 3, another 1 and negative 2. So my range is, my lowest is negative 3 and my highest is 1. Y values, I have a 4, I have a 2, a negative 4, and a negative 3. So my range would be, my lowest is negative 4 and my highest is positive 4. Again, this is what I'm looking at. I notice they're all low numbers between 1 and 4. Or I should say negative 4 and positive 4. So I can easily skip count by ones. So I'm just going to do some little tick marks. 1, 2, 3, 4. Same thing up here. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Negative 1, negative 2, negative 3, negative 4, and 1, 2, 3, 4. Negative 1, negative 2, negative 3, negative 4. That's all you had to do, guys, and then just plot these points over here. So we have 1 and 4 is up here. This is A. We've got B is negative 3, positive 2. That's right here. This is B. We've got 1, negative 4. I'm kind of going to dot over my 4. That's okay. That's C. And then I have negative 2, negative 3 over here. That's D. So hopefully yours looked like mine. If you did, good job. Number 2, Diego was asked to plot these points. Here's 1, 2, 3, 4, 5 sets of ordered pairs. What interval could you use? So this time you're going to figure it out without having to even draw the whole coordinate plane. So I'm really going to pay attention to my X range and my Y range. I see that these are big numbers, okay? Negative 250 up to 350. So I would say a good interval, I could either use 50s or I could use 100. So either answer 50 or 100, okay, would be okay for you guys to use in your answer. Number 3, name 4 points that would form a square with the origin at its center. So if you had this type of a design, what could the 4 points be so that when you connected them, they'd make a perfect square? So there's multiple numbers you could use. The key is they have to be the same number. So A is our positive, okay? So let's see, we went over 2 and went up 2. 2 and 2. B would be our negative and then positive. It has to be the same number, so we'd go over negative 2 and up 2. C is where we have our 2 negative. Negative 2, negative 2. And D would be positive 2, negative 2. Positive and then a negative. So you could have used 3s or 4s. You could use any numbers as long as they were the same and their negative positives matched what coordinate that they were in. Number 4. Which of the following changes would you represent using a negative number? Explain what a positive number would represent. So first of all, we're looking for only the negative numbers. I did A for you so you could see what you have to do here. A loss of 4 points. That's represented by a negative number. Then it says explain what a positive number would represent. Well, a positive would be a gain of 4 points. B is a gain of 50 yards. Well, this is a gain. Okay, so it's not going to be represented by a positive number. C, a loss of $10. Well, that is a negative number. It would be negative 10. And explain a positive outcome. How about just simply a gain of $10? And D is an elevation above sea level. That would be a positive number, so that wouldn't even count. Next page. Jade is buying books for school. The cost of each notebook is $1.75. A says write an equation to show the cost of Jada's notebook, C, in terms of the number of notebooks N she buys. Well, if each notebook N costs $1.75, we could always figure out the cost by simply taking $1.75 times N, the number of notebooks. That you buy 1 notebook, 2 notebooks, 3 notebooks, and you'll be able to always get the total cost. So if Jada does in fact buy 4 notebooks, how much will it cost when N is 4? Well, hopefully you just took $1.75, multiplied it by 4, and got $7. Last but not least, number 6. A cornfield has an area of 28.6 acres. It requires about 15 million gallons of water. About how many gallons of water per acre? So because we have about how many, we can round. All right, so hopefully you rounded 28.6 up to 30. I gave you a hint, a whole number. Step 2 is simply then to take that 30 and divide it into the 15 million. Well, 30 goes into 150 5 times. So the rest, simply going to fill in with zeros. So our answer is 500,000. I'm looking over, not 500,000. Yeah, I'm looking over here. Did I do that right? Hold on a second. And the correct answer is C. Boop. All right, guys, have a great rest of your day, and we'll see ya for the next math lesson next time.